Let's break down the differences between normally open and normally closed in both physical devices and ladder logic programming. Understanding these differences is essential for creating accurate ladder logic programs that reflect the behavior of the physical devices they control. It's like speaking the language of machines and telling them what to do. The example below will provide you with a better understanding. Keep in mind that the processes within the PLC are more complex, but for the purpose of enhancing your ladder programming skills, this assumption proves to be quite helpful. While creating the ladder program, we incorporate normally open and normally closed contacts. This entails assigning normally open and normally closed contacts within the PLC. Take note of these. They represent the contacts we allocate in our program. In cases where no signals reach the inputs, indicating the input states are at 0 volts, these contacts respond in a corresponding manner. Observe this. A 24-volt signal is directed exclusively to the X2 input of the PLC through the emergency switch, because it is a normally closed switch. As a result, the associated X2 contact closes. If we press the Start Push button, a 24-volt signal will be sent to the X0 input pin of the PLC. As a result of this signal, the corresponding X0 contact in the PLC's logic will close. All three logic contacts associated with X0, X1, and X2 are now closed. Consequently, a 24-volt signal can pass to M0, an internal memory bit of the PLC. If M0 was initially low, it will now be high. What happens when we release the Start Push button? The 24-volt signal, previously provided to X0, is suddenly interrupted. As a result, the contact associated with X0 opens again, causing the M0 memory bit to return to a low state. If the M0 memory bit should remain high even after releasing the Start Push button, you need to insert a normally open contact of M0 in parallel with the contact related to the X0. This is referred to as latching. In this configuration, when M0 is initially high, the contact associated with it closes, allowing the 24-volt signal to pass through it, even if the contact related to X0 is open. Alright, now, if we press the Reset Push button, a 24-volt signal is directed to the X1 input, causing the contact linked to X1 in the ladder program to open. As a result of this, M0 returns to a low state. Even after releasing the Reset Push button, M0 will not return to a high state until we press the Start Push button again. Alright, now let's jump into the ladder program that meets the requirements of the box sorting process we talked about earlier.